Welcome to week 8 of our Python lesson, Python Bootcamp course. And so today we'll be continuing as part of schedule. With week 8, we'll be doing part 2 of advanced programming. And the volunteer staff and I have decided that we will be also doing some review today. So if you've had any trouble with any of the previous sections for the class, let's go back. So if you were wondering something about the fundamentals, or if you had some doubt about data structures, or if you had some problems with object-oriented programming or anything like that, be sure to ask your question and we'll do our best to answer it. Okay, so let's go ahead and get into it. But before that, let's take a look at so the check on the final projects. Most people said that their final projects are coming great. So just a reminder, the final projects will also help determine whether you'll end with a certificate or not for this class. So be sure to do the final project. So it looks like most of you have chosen to create a game for your final project. So be sure to try to finish that up as we're coming to our last stretch of the course. Okay. So today we're going to focus on, or we're going to start off the class with an important concept, which is getting help in when it comes to Python programming. So when it comes to getting help, help is no stranger in programming. People in Google, IBM, big companies, with lots and lots of experience, even they need to still get help from the internet. There was a developer conference from some time ago where some representatives of Google came and they announced that, and one of the questions they were asked were, do Googlers, the Google developers, do they Google questions that they have? And they said, yes, they do Google questions that they have all the time. Whenever they need, nobody can remember every single tiny detail about Python. So it's important to remember that you can always Google different parts of the language whenever you need help. It's also a really good practice to know how to get help, but at the same time, you don't want to plagiarize. So what is plagiarism? Plagiarism is when you're copying and pasting something you're copying and pasting something, and you're basically just blatantly using something that's not your own work, but you're claiming it as if it is. So let's say you go to a quiz, right? So let's say you're taking one of our quizzes, and then let's say you're taking one of our quizzes, right? And let's say you need some help with a problem. So you go to Google, right? And then you just copy and paste the problem. So like maybe the problem is to like some numbers in list Python, right? Like that. And then you go to maybe some random website, and then you just, you see some Python code and say, hey, this Python code is exactly what I need for my problem. So then you just do Control-C to copy, you go to JGrasp, and then you paste that, right? But anyway, let's say you did that, and it worked for you, right? Like if I did this, I'll just call it class. And you did this and say, oh, hey, this does exactly what I wanted to do. Maybe I'll just change one number or something, right? This is an example of plagiarism. You're copying and pasting work that isn't your own, and you're not citing it or anything like that. So this is an example of plagiarism and what not to do. Most companies and large institutions, they really do not like plagiarism. Especially, in fact, they hate plagiarism so much that they often the consequences that come with plagiarism in these large institutions can be very severe. So this can include things like being removed from institutions altogether. Like I know Harvard University, I think their policy for plagiarism is that if they find plagiarism, a student that's using work that's not their own, they consider that as cheating, and sometimes they'll even remove the student from the college altogether. So plagiarism is something that's it's a very negative concept, and you should always avoid it no matter what the circumstances. An example of getting help for Python, however, when it comes to like what I said about the developers from Google and large tech companies, when they get help, their example of help would be something like if let's say that they make a mistake in their program, right, like that, and then they get an error here. So then what they might do, is they would highlight the error and then copy and paste their error, right, like this. If they go to, and then maybe they'll go to Google and then just paste the error into there, right? And then when they paste this error, maybe there will be, there's a website known as Stack Overflow, which is a website for where people often ask questions about Python programs, about their Python programs not working. And a lot of times, people on here will have the same questions that you might have. So maybe if your question was how to sum a list in Python, like that. There will almost always be a Stack Overflow for your relevant problem. But remember, you don't want to copy and paste Stack Overflow answers. Instead, what you should do is you should just try to understand their concept. So here they're saying, okay, so to take the sum, you read what they're saying, first of all. So then here this person is saying that to sum everything, they're going to use this function called zip to take pairs from two lists. And then they're going to do some more things, discarding the remainder, all of that. And then they also say that you can also just use the sum function to solve whatever problem that this person had. So then you might say, okay, the sum function, let's try that. And then you could go to your Python program. What is it? Okay, yeah, then they could go to their Python program and say, if I'm trying to sum this list of numbers, maybe I could use the sum function. So maybe just print and then sum of numbers. And then now that you understood the concept and it does exactly what you want, this is the proper way of getting help in most cases when it comes to programming. You don't want to blatantly copy and paste. Whenever there's a teacher around, like us, where you can just email, or you can email us. We gave you our email, python.help@takeakshan.org. I'll even type that in here in the chat. Or if maybe you're taking a class and you need some help with the assignment and it's related to programming, then ask your teacher. But no matter what you do, do not copy and paste work that's not yours. All right. So does everyone understand how to properly get help in Python? What's wrong with this? Does anyone have any questions when getting help? These are some useful websites that offer explanations for concepts. Notice that when I tried to look up how to find the sum, this program over here calculates the sum in the exact same way as this program over here does. So in a way, I'm still using the advantage of what these programs on the internet are using, and I'm also avoiding plagiarism as well. So there's no guilt in this. This is perfectly fine. And so that's the proper way to get help. Okay, so let's see, we have a question. How do you submit the projects? So we'll be releasing more information on how to submit the project as we reach the deadline through email. On some more information, the exact location you need to upload your project or submit your project, and all of that, all those formalities. Can you use help menu in the Python terminal? Yes, you can also do that as well. But when most people have problems or they need some help in Python, it's usually because of an error in their Python code that they cannot figure out. So let's say I'm trying to do this, right? Maybe this is a very complicated, maybe there's a very long and complicated Python program, and you can't find out what's wrong with the Python program. So then you copy and paste the error, which arguably outdoes the Python help function. But yes, there is a help function in Python that you can use where you type in help, and then you can type in some kind of function or something. So if I said sum, like that, try this. Okay. Anyways, you can look into it if you're interested about the help function, but I haven't seen many people use this. Obviously, there are different preferences for different people, but anyways, if you type in help into your Python CLI or command prompt, then it will give you more information on using it. Or you can just Google, look for guides or tutorials on how to use the help function. There are actually lots of helpful tutorials on Google whenever you're trying to solve a Python problem. So maybe, let's say you're a data scientist, right? So, and you want to try to analyze data. So you could just look up analyze data, Python, and then tutorial, right? Like this. Okay, why is it on Yahoo? Go to Google and type in the same thing. Like that. And then there are lots of tutorials on places like YouTube or on different websites as well. And then once you take these tutorials, then this should hopefully help you. These tutorials will hopefully help you understand the concepts. And then you can actually use the concepts you learned into your own, whatever you're trying to accomplish. All right, so that's how you get help in Python. Let's continue to the advanced part of programming we were going to go in today, which was NumPy. So does anyone know what is NumPy before we go into it? Would anyone like to take a guess what NumPy might be? Okay, so someone said the numerical pi value. Remember, we do have the numerical pi value in the math library when we can just say import math and then say math.pi, and then this gives us the value of pi. So maybe it's not that. Any other guesses? Short for number Python? Yeah, perhaps, maybe it is. But what exactly is NumPy? Okay, so guesses aside, NumPy is it's a library that you can use in Python, and it helps you when you're dealing with lists. So maybe in this class you found lists to be very helpful. If you haven't found lists to be very helpful, don't worry. Eventually, if you go into Python programming a lot more, you will find that lists are very helpful in Python. So here we have a list, right? Let's say L is equal to list. Okay, and then let's say we want to have a list of lists. So then I could say L, comma L, comma L, like that. And we have 3 lists inside of a list. And then maybe I wanted to have this giant list inside of an even bigger list. So I could do that. You can see where things can get a little, they can get a little confusing as you go into this, right? if you're maybe trying to do something really weird, like maybe you're trying to, maybe you're running a store or something, and you want to manage everyone's data inside of a list, right? So let's have this list here, and this list here, and this list here, right? Like that. And then, you have to count the brackets for each thing. I think this one needs another bracket maybe. Let's see if that works. Okay. And you can see this can get really confusing really quickly. So anyways, here we have a list. We have these smaller lists inside of this big list. Okay, let's say that this big list is T, right? And then when we say T, it can get pretty confusing. So, well, anyways, with NumPy, we have what's called an array, and more specifically an ND array. So what an ND array is, it's an n-dimensional array of numbers. So it's really similar to a list in terms of functionality and how you can use it. So let's take a look at it. So first, what we should do is we can say import NumPy as NP. So notice I didn't just say import NumPy. I said as NP. Can anyone guess why I did this? Okay, so the reason I said as NP is because NumPy can get pretty. Let's say that I import NumPy like this. Okay, so now if I want to make an array, then I have to say NumPy dot ND array, and then I need to say the array that I want to make. So maybe 1, 2, 3, 4, right, like that. And then I easily made my I made this list with these dimensions, right? But before we get into that, notice here I said NP. So the reason that you could say as NP is just for making things short and simple. Okay, so I'll close this Python CLI and I'll open a new one. And but this time let's import NumPy as NP. So we're adding as NP at the end. So what this does now is instead of saying NumPy dot ND array like that, now all I have to do is say NP dot ND array like this. So it shortens. It basically it's like this short text that you can abbreviate NumPy with. So instead of having to type in the word NumPy every single time you want to create an array, now you can just say NP. And NP is commonly used when importing NumPy. That's kind of the standard. Okay. So now let's say, now that we can create an ND array, let's take a look at the dot array function like this. And now we can create arrays like 1, 2, 3, 4. Let's add a 5, like that. So now we have an array. Let's store this in a variable. Let's call it x. Okay, so now x is this array. So now, what can anyone guess what would happen if I said type x like this? What would I get? What would be the type of x? Okay, so x is type NumPy ND array. So we have an n-dimensional array. Now I'll type that out so you guys can see it. Okay, so this was our thing from before. Make a new one. Delete this. Okay. So when we have an array, right? We can make that array. So for now, just assume that an array is the same thing as a list. They're not the same thing, but we'll get into that later. So, but pretend that an array is a list, is the same thing as a list. So before we mentioned that you can have a list inside of a list, and then you can make that list inside a list like this. And you can do this as many times as you want, but over time this can get really complicated and confusing, especially if maybe you want to make a lot of arrays or a lot of dimensions in your array. So let's define what a dimension is first. So a dimension is sort of this concept of being able to, I guess, sort of expand your or measure your object in different ways or different dimensions. So when people say that they have a when people say that they're working on a 2D plane or 2 dimensions, or let's say that we know that a paper is 2D, but have you ever thought about what 2D really means? So 2D actually means 2 dimensions. That's what the D stands for. So when they say that a paper has 2 dimensions, it's 2D, they mean because the paper, you can measure the paper in 2 sort of ways, or 2 dimensions. Oops. Anyways, there is this dimension, right? And there's also this dimension as well. So there's a length and a width for a rectangle. A rectangle has 2 dimensions. But then maybe you're wondering, well, if this is 2D, then what would be 1D? Well, 1D is basically just a line, right? So 1D, a line would be 1D, or 1 dimension. Okay, so this should be pretty simple. You can measure a line in one way, right? You can only measure a line from one end to the other end. It only has 1 dimension, 1D. So let's think of a line as a list. If we had a list, right? Let's say we had a list, and this list had the numbers 1, 2, 3, and 4, or maybe 5. Okay, so we can measure this list in one way. It has a length. That's it. We're not worrying about the value of each element or anything like that. This can be measured as it only has 1 length. Yeah, whatever. Okay, it only has 1 length. And then let's say that we had a 2-dimensional array, like this, or 2-dimensional list. So a 2-dimensional list can be thought of a list inside, or a number of lists inside a bigger list. Okay, so let's say that there are all of these lists here. And then on the outside, all of these lists are inside this giant, big giant list. Okay, so now when you think about it, how many lengths does this list have? Well, there are 5 lists inside this list, right? So this list, this giant list, has 5 elements. What are the 5 elements? The 5 elements of this giant list would be each of these lists. So this list over here is an element, 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 and this list over here is an element. So this, in this dimension, it has a length of 5. But there's also another dimension too. We have a dimension in each of these inside inner lists. So this dimension over here is also length 5, because there's a 1, there's 2, there's 3, there's 4, there's 5. There's 5 elements inside each of these tiny lists. So that would be the second dimension, right? Is everyone with me so far? Okay. So then we have the third dimension, right? Which is the dimension that all of us live in. 3 dimensions means that everything has, when we say that something is 3D, that means it has 3 dimensions. So that means that everything has a list, or a length, a width, and also a height as well, right? So now that we have 3 dimensions, think of it as this giant list. So a number of these giant lists inside an even bigger list. Okay. So let's do that. And it might be a little bit difficult to represent that here. Maybe I'll try representing that in, let's try Fusion 360, perhaps. That would help better illustrate this. If that loads. But anyways, while that's loading, if it even is loading, let's try to visualize what this might look like. So with this line, we have one length. But then when you combine a number of these lines and put them all, squeeze all of them next to each other, you get this two-dimensional object, right? So naturally, when you think, intuitively, when you think about it, when you squeeze a number of these two-dimensional objects together, you could get a three-dimensional object as well. So could anyone guess in the chat what this three-dimensional object would be, following our logic? Okay, so some of the guesses are cube, 3 by 3 by 3, rectangular prism. So yeah, all of these are pretty close to what I was hoping you'd say. Let's taking some time to load. Go back to paint. Finish that? Nope. Okay. Maybe this is done. So in geometry, how many people would say that they're strong in geometry? Okay, so we have a couple of people, but not everyone seems to be strong in geometry. So let's try to let's visualize this in this the new design. Okay, I guess it is. Maybe it updated. So anyways, so here we're in this plane. Okay, whoops. Let me move some stuff out of the way. Okay, so we're in this plane here. What is a plane? A plane is just some area of space. So somewhere in the world, this is what it looks like. Not literally, but figuratively. So let's say on the ground, so this is the ground, there's a, let's say we have a rectangle, right? Like this. Okay. Okay, and then, so if you think about it, a rectangle is really just a, what's going on? A rectangle is really just this a bunch of lines, right? So let's take a look at a rectangle, or I guess this is a square, but a square is also a rectangle, remember. So let's look at the length of this. I think it's m, maybe. Yeah, or no, it's not m. Okay, it's been a long time since I've used this. But anyways, hopefully all of you understand that if I put a bunch of these lines next to each other, it makes up a rectangle. So let's, no, that's not what I wanted to do. Okay, so when I extrude a rectangle like this, when I have this two-dimensional object, and let's say I stack a bunch of these rectangles on top of each other, then I get this, what do I get? I get this sort of rectangular prism or cube. I can change it to whatever I want. So this represents the third dimension, right? I guess it went away. But anyways, you guys all saw that. So let's go back to our board. And so this list, as we have it, we can add another third dimension as well. And then we can have lots of these lists on top of each other. So what would that look like? That could look something like maybe we have these lists. So let's say this list is 1, 2, 3, 4, 5. Or you know what? Let's try to keep things, the drawings a little simpler. So we have this this two-dimensional array, and then let's say we wanted a let's increase this thing by a little bit. Too much. Oh. Okay, so let's paste this list. It's a little small. At least now we have more space. Okay. Anyway, we have a bunch of these lists next to each other, like this. And then all of these lists over here, we're going to put all of these lists inside one giant big list. Okay. So let's take this and let's move it. Maybe let's move it down. Okay, so all of this is in an even bigger, ginormous list. That's 3 dimensions. Okay, so hopefully this helps all of you understand what making a understand the dimensions of that you can create a list with. So here, this list has a dimension over here. It has a dimension over here, where you have multiple of these lists, and it also has a dimension over here. So we have one list over here, another list here, another list here. So this list has a length, this giant list has a length, this smaller list has a length, and this even smaller list also has a length. Okay, so type in the number 1 if you understood this. Okay, all right, let's close this. You know what, actually, let's keep it open in case someone needs to refer to it later. Okay, so when we have a NumPy, when we want to do NumPy, create a NumPy array, you can think of this sort of like a list. So here I have an array that's one-dimensional, like this. So X is this array, and X also has the attribute called shape. So when I do x.shape, that will print out the dimensions of this object, of this array. So the shape of this array is 5, right? And it's only in one dimension, so that's why there's only one number. So here there are 5. This has length 5 in this first dimension, so that's why That's why the shape is 5. And let's try getting a little bit more creative. Maybe this is an ND array like that. So X. Now there's a lot more dimensions. So let's try to find out the shape. X.shape. And now there's the first dimension is 1. So there's 1. The length of this giant list is 1. And then we have 2 smaller lists over here. So this there's a list over here, I guess. And there's another list over here. This over here is 1 list too. And then the next dimension is 3. So inside that list, we have these 3 smaller lists over here. And then inside those 3 smaller lists, there are 4 lists over here. So here's 1, here's 2, here's 3, and here's 4. And then inside that, we have a list that's length 5. So the length of this list is 5, the length of this list is 5, the length of this list is 5. Okay. So does everyone understand what a shape is and the dimensions, what dimensions are when it comes to Numpy arrays? Type in 1 in the chat. If you have a question at any point, type in your question. All right, so maybe you're wondering, well, I know that if I have a list, right? If I have a list and it's 1, 2, 3, 4, 5, like that, let's say this is, maybe this is S. S is that list. So maybe you already know that S, if I want to find the index of like maybe index 4 or something, whoops, slash, then all I have to do is type in this with brackets and then the index I want, like this. And then it would give me the value at this index. The value at index 4 is number 5, right? So you might be wondering, well, how do I do that if it's a crazy list like this? Well, let's take a look at it. Would anyone like to guess how we might do that? So let's create an array that's 2 by 2. How about that? So now X is a 2 by 2 array like that. All right. So would anyone like to guess how could we in a 2 by 2 array? So X is this 2 by 2 array. How could we access maybe like this element? How would you access this element in this array? Just type in what I would type in here to access this element. Okay, so someone said x.2. It's not x.2. Remember that 2 is a number, an object, and objects can, and this primitive data type cannot be an attribute for x. Okay, so we had some pretty good guesses. Someone said something like this, 2, 2, both square parentheses. Okay, so like that. I don't know, maybe you meant to put x here, but anyway, that's a close, pretty good guess, but that's not the one we're looking for. So how you would do this is remember that when we're counting indices or indexes, the first index is 0 of an array, and then the second index is 1. So if we wanted to get this one, we'd first look at the value for this outer array. So the value that we want to get is in the second element of this outer array. So this outer array has 2 elements. One element is this list, and the other element is this list. So, but the one that we want is in this list over here. So we want to get the second element. So the second element, we get that by adding the second index, which is x1, like that. So that gives us the second element of this array. So the second element is this, and from that, x of 1, we want to get the first element, right? Because I said we wanted this one. So after we found the second, the smaller dimension, which we wanted, so notice that the dimension reduced by 1. So this we lost a dimension from here to here because we're only taking this dimension. Now, if we want to get this value over here, this is the first value of this dimension, or this list or array. So how we get that is we just add a 0 at the end, and this gives us this this value over here. So you might be who's confused by all of this? Type in 2 if you're confused. Type in 1 if you understand, and then type in 0 if you don't understand. Okay, so why does it have 0.0 in return? Well, that's because, remember, we were trying to get this value over here. So in a list, if maybe the list is like z is equals to a list 1, 2, 3, 4, let's have something there, 5. That's not in order, but let's just use it as an example. And then, or you know what, a better example would probably be to number everything according to the indices. So 0, 1, 2, 3, 4, 5, like that. Okay, so when we have this list, right, and we wanted to get maybe like this, we wanted to get the value at index 2. So all I'd have to do is say z of 2, like that. But what we're trying to show now is what would happen if maybe z was, or maybe we have this giant thing called y. So maybe y is going to be a list. And in this list, there are, we have z. So like this, right? So now if I get y, now y is this list of lists, like that. So now if I wanted to get, maybe if I wanted to get this value over here, first I'd go to this first element in this giant list. So I'd say y of 0, like that, which would give me this first list. And then after that, I'd say y of 2 and then I'd add the number, I'd add the second index that I'd want. So first I'm getting the first list, and then I'd want the first element of that list, like this. Or actually we wanted the index 2 of that list, so like that. And that gives us the value at this area. Okay. Why is it 0.0 instead of 0? Well, that's because when we made our array, we made it an array of floats, like that. So that's why so inside this part of the NumPy array, we got a float. So 0.0 is the float that's inside this NumPy array, like that. Okay. So let's take a look at some of the helpful uses you can do with this. So there's a Reshape tool as well in when it comes to NumPy arrays. So let's create an ND array, np.nd array, like that. So it's an n-dimensional array, and maybe the shape of this array is like 3, I don't know, maybe 4, like that. Okay. Oops, what happened there? Oh, oops. Did I mess something up? Okay, you know what, to keep things simple, let's do 2, 2, like that. Maybe I messed something up there. Okay, but what the Reshape tool does, So let's assign a variable name for this. So let's call it v equals this array. So now when I type in v, it gives me the array. But what the reshape tool does, remember that we can get the shape of the array like this. So the shape of this array is 2 by 2. So we have 2 elements here, and it's also has 2 rows. What the reshape tool does is it actually lets you change this shape here. So let's say v.reshape, and then let's type in the shape that we want. Maybe we want to have a 4, like that. So now it changed this shape. Before this was the shape. It had 2 dimensions. There's 1 dimension here, 1 dimension here, right? So this was 1 dimension, and this was 1 dimension. Or no, this was 1 dimension, and this was 1 dimension, right? So it has 2 rows and 2 columns. But now we changed it, so now it has, or it has 2 columns and 2 rows. Now we changed it, so now it has 4 columns and 0 or 1 row, right? So all it has is just these 4 different elements inside this 1-dimensional array, right? Like that. So this is it's only 1 dimension. It only has 1 dimension, and the length of that dimension is 4. That's probably a better way to put it. Okay. So does anyone have any questions or anything about this? Is everyone good so far? Try 4, 4. Okay. So you can see that now when we're dealing with more complicated lists like this can be very useful, right? So let's say v.reshape. And then would anyone like to give a suggestion of what they'd like to reshape this into? Let's do 6 and then maybe 2, like that. So we have 4 by 4, right? So this means that there are 16 elements inside. So there are 16 of these zeros. But now I tried to shape it into a 6 by 2 array. So can anyone guess what this error might mean here? I tried to shape this 4 by 4 array into a 6 by 2 array. Would anyone like to take a guess at this? Yeah, that's right. The number of elements don't match up. When I have 16 values here, and I try to put that in an array that is 6 by 2, like this. Let's go back to Paint so I can help draw this for everyone. It looks like some people might have some trouble understanding. Okay, maybe we can do something with this. Or no, let's just do this. Okay, so we have small. So let's say we have this array, which is just a bunch of these smaller. So we have an array. We have an array that has a lot of these smaller lists inside, like this. Okay, so and then so this array has 8 elements inside, right? But let's say we want to reshape this into maybe an array that is. Let's say we ran the command to change this into an array that maybe had size, I don't know, 2 by 2, right? So let's say 1, 2, 1. So as you can see, there are some sizes that just simply don't work, right? Because when we have this, the array above clearly has a lot more elements than this array down here. So Python won't know what you want to do, what exactly you're trying to do with these bottom 4 elements, right? It makes sense where you're trying to put these top 4 elements, right? You simply just want to put these here, or maybe just, or it doesn't really make sense which elements you're trying to put here. The size is obviously smaller into this place. So that's why if I try to reshape a 4x4 array into a 6x2 array, it won't work because there aren't enough spots for all of the elements to fit in a 6x2 array. So that's why this doesn't work. That's right, alternately, I could just do an 8x2 array. This would work. So now I reshaped this array. Before it had 4 rows and 4 columns. Now it has 8 rows and 2 columns. So I was able to reshape it just really easily like that. So that's the power of Numpy arrays. So Numpy arrays also have, they have some more methods as well. There's some complicated advanced indexing that you can try out. There are different functions you can use to try to raise values to the power of something. So you know what, let's try that. Just for demonstration purposes, let's say let's say we want to make an array, let's call it A, and then np.array. And let's say that maybe this is a 2x2 array. So let's say this is like 1, 2, and then the second one is maybe 3, 4, like that. So this is the array that I just made called A. And let's try the first one. So NP. So while I'm typing this, can anyone guess what this does? Yep, that's right. This raises it to the 3rd power. So 1 raised to the 3rd power is 1. 2 raised to the 3rd power is 8. 3 raised to the 3rd power is 27, and 4 raised to the 3rd power is 64. And notice this here, this gives me the data type, the type of data that is in this list. So recall before, when we made this, the default data type was a float. We made, this is a NumPy array filled with floats, but here the data type are 32-bit ints, 32-bit ints. So in case you're a bit is just, someone was joining late, but anyways, bit is just like a unit of computation, so, or compute memory. So recall that there's a bit, which is on a smaller scale of compute memory. There's also a byte. There's also megabytes, and then kilobytes, gigabytes, and all of that kind of thing. So as you can see, but all of that does come into play sometimes, but in most cases, you won't be dealing with the data type between int 32 and maybe something else like int, I don't know, 64 or something. But anyways, as you can see, we were able to make this NumPy array with ints. Okay, so we also have the mean as well. So let's try using the mean function. np.mean and then a, and then I think we also have to say a row as well. Row. Let's try 1. What was it? The argument row. Let's get rid of that. Okay, so this gives us the what is it? The mean of all of these numbers. So we have 4 here, 3, 2, 1. When we add all of this up, we get 10. 10 divided by 4 is 2.5. So that's the mean, the average of all of these numbers. In case you don't know what the mean is, the mean just means that you add these numbers, and then you divide it by the number of numbers that you added. So here we added 4 numbers, and then we divided it by 4. There's a question, what would we use these arrays for? So you could use these arrays for pretty much anything, right? You could use these arrays when you're working with complex numbers, when you're working with higher math. Maybe you're trying to store some scores. Maybe you're creating a game, right? Especially if your game is using pictures or something. Maybe if you're trying to do some photo editing. A lot of times the pictures, so if I, that's a good question. Let's actually look up a, okay, I want to pull up one of the projects I've done, but I'm afraid we don't have time to look all the way into that. But basically, to answer your question, whenever we get a picture, like let's say, I'll just Google some random picture, maybe a picture of a tree. Google and then type in tree, like that. So here we have a picture of a tree, and this picture, it has these colors, right? So here there's a dimension. So this picture, it says 220 by 293. So that's the dimension of each of the pixels in this picture. So so when we try to convert this picture, you can do some research into that if you're interested. You can convert this picture into a Numpy array. So this Numpy array would have 220 rows, 293 columns. And each element in that Numpy array would be like the, maybe let's get a black and white picture. Tree, black and white. Okay, I like this picture. Let's take a look at this one. So here we have a picture. This picture is 570 by 570. So this is 570 pixels by 570 pixels. So there's actually a library in Python where you can take this picture and it will convert this picture into a Numpy array. And this Numpy array will be 570 rows by 570 columns. And each element in that Numpy array will be a value. And that value will represent how dark that pixel is. So maybe this, if I go to Paint and I want to edit colors, you can see that there's a, let's move this out of the way. Okay, so there's a, I can edit colors like this. There's a RGB, so red, green, and blue. So if I wanted to get a certain color, I could type in a number. So maybe there's 120 red, 0 green, maybe there's like 25 green in this color. Maybe there's like 300, or no, 255 is the maximum value. So I shouldn't have said 300. Maybe there's like 250 blue. And so when I have these RGB values, I would get this color. And this color would represent this pixel, each pixel in this giant Numpy array. Okay. So I know that was a lot, but if you're interested in this, there's actually a lot of state-of-the-art research that's going on in that exact question that you asked about. What would we use these Numpy arrays for? And that's just an example of what you would use Numpy arrays for. So that's a great question. Does anyone have any more questions about anything I explained so far? As we wrap up, it's 12 o'clock now. If you have any more questions, ask them in the next minute. We'll wait for one more minute. Okay, it doesn't seem like there are any questions now. If you're in the middle of typing a question, just press enter. And just so I know that you were asking a question, and then maybe complete the rest of it after. We'll wait for a few more seconds. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, so nobody has any questions, so we're going to end the lesson for today. Thank you so much for coming. We'll send an email probably around Monday or Tuesday, sometimes even Wednesday, or depending on the time limit that we're allowing for our next quiz. We didn't go over the quiz from last week today, but the results, that was mainly because the results of that quiz seem to be relatively good compared to previous quizzes. If you do have any questions about the previous quiz or anything, make sure you ask it at some point, because we're almost done with our entire course. You can see our next week is our last class, and in this class we'll be covering some important odds and ends when you're trying to work on Python in the future. So that wraps up our session. Thank you so much for coming, and we'll see you next time.